Suppose that real number x satisfies 5 times tan to the 6th x plus tan to the 4th x plus tan squared x plus 2 to the 60 times sine to the 10th x plus cosine squared x equals 2 to the 60. What is the sum of the digits of tan squared x? We have this number tan squared x, and I'm going to call it u. And we would like to find u. Almost the entire equation is written in terms of u, except for two terms here, which are written in terms of sine squared x and cosine squared x. But we can find those pretty easily in terms of u. We know that sine squared x plus cosine squared x is equal to 1. And sine squared x over cosine squared x is equal to tan squared x, which is u. It's not too hard to see based on these equations that sine squared x is equal to u over u plus 1. And cosine squared x is equal to 1 over u plus 1. So now we can write the entire equation in terms of u. We have 5 times u cubed plus u squared plus u plus 2 to the 60 times sine to the 10th x, which is sine squared x to the 5th, and that's u over u plus 1 to the 5th, plus cosine squared x, which is 1 over u plus 1, and that's equal to 2 to the 60. We would like to solve this equation for u. It would be easier to solve this equation if we multiplied everything by u plus 1 to the 5th to help clear the denominators we don't want. So let's do that. We have 5 times u cubed plus u squared plus u times u plus 1 to the 5th, which is u to the 5th plus 5u to the 4th plus 10u cubed plus 10u squared plus 5u plus 1 plus 2 to the 60 times u to the 5th, since we cleared away the u plus 1 to the 5th denominator, and then plus u plus 1 to the 4th. This is equal to 2 to the 60 times u plus 1 to the 5th. Now let's focus on the first term, this one. So let's expand u cubed plus u squared plus u times u plus 1 to the 5th. So first we have u plus 1 to the 5th, all the terms, times u cubed, which is equal to 5 times u to the 8th plus 5u to the 7th plus 10u to the 6th plus 10u to the 5th plus 5u to the 4th plus u cubed. And then all the terms times u squared, which is u to the 7th plus 5u to the 6th plus 10u to the 5th plus 10u to the 4th plus 5u cubed plus u squared. And then we have all the terms of u plus 1 to the 5th times u, which is u to the 6th plus 5u to the 5th plus 10u to the 4th plus 10u cubed plus 5u squared plus u. So when we add this all up, we get 5 times u to the 8th plus 6u to the 7th plus 16u to the 6th plus 25u to the 5th plus 25u to the 4th plus 16u cubed plus 6u squared plus u, which is 5u to the 8th plus 30u to the 7th plus 80u to the 6th plus 125u to the 5th plus 125u to the 4th plus 80u cubed plus 30u squared plus 5u. And then what do we want to add to that? Well, we want to add 2 to the 60, u to the 5th. And then we want to add u plus 1 to the 4th, which is equal to u to the 4th plus 4u cubed plus 6u squared plus 4u plus 1. Let me put this 2 to the 60, u to the 5th where it belongs down here. And there we have it. That is equal to 2 to the 60 times u plus 1 to the 5th. So all this is equal to 2 to the 60 times u plus 1 to the 5th. So now let's put this expression in simplest form by combining all the terms of the same degree in u. So we have 5u to the 8th plus 30u to the 7th plus 80u to the 6th plus 125u to the 5th. I'm going to keep that separate from 2 to the 60 because it's a really large number, u to the 5th, plus 126 u to the 4th, plus 84 u cubed, plus 36 u squared, plus 9u plus 1. And all this is equal to 2 to the 60 times u plus 1 to the 5th. Now the 2 to the 60 u to the 5th is kind of out of place on the left-hand side, so let's move that to the right. And we get that this is equal to 2 to the 60 times u plus 1 to the 5th minus u to the 5th. So now what we do? Well, we look at the left side, and we notice these numbers, 126, 84, 36, 91, which we immediately recognize as 9 choose 4, 9 choose 3, 9 choose 2, 9 choose 1, etc. And those are the binomial coefficients which we would find in u plus 1 to the 9th. So let's write the expansion of u plus 1 to the 9th down below and compare these terms to u plus 1 to the 9th. We have u to the 9th plus 9u to the 8th plus 9 choose 2 u to the 7th, which is 36 u to the 7th, plus 84 u to the 6th, plus 126 u to the 5, and then all the remaining terms are the same as these ones. So what do we have to subtract from u plus 1 to the 9th to get what we have up here? Well, first of all, we have to subtract u to the 9th. We also have to do 4u to the 8th. We have to do 6u to the 7th. We have to do 4u to the 6th. And we have to do u to the 5th. So u plus 1 to the 9th minus this is equal to 2 to the 60 times u plus 1 to the 5th minus u to the 5th. Now again, we notice something special here. 1, 4, 6, 4, 1. Those are the coefficients of the binomial expansion of u plus 1 to the 4th. So we recognize this as u plus 1 to the 9th minus u to the 5th times u plus 1 to the 4th. Because the exponents of u are 9, 8, 7, 6, 5 instead of 4, 3, 2, 1, 0. That's why the u to the 5th is here. We multiplied u plus 1 to the 4th by u to the 5th to get this. And that's equal to 2 to the 60 times u plus 1 to the 5th minus u to the 5th. But we can also factor this out of the left side. We know that this is equal to u plus 1 to the 4th times u plus 1 to the 5th minus u to the 5th. Equal to 2 to the 60 times that stuff. So we can cancel out this u plus 1 to the 5th minus u to the 5th. And we get u plus 1 to the 4th equals 2 to the 60. And now we have u plus 1 equals 2 to the 15th. So u is equal to 2 to the 15th minus 1, which is equal to 32768 minus 1. And that's equal to 32767. Going back to the problem statement, it wants us to find the sum of the digits of u, and u is 32767. So we want 3 plus 2 plus 7 plus 6 plus 7, which is 5 plus 13 plus 7, and that's 18 plus 7, which is equal to C, 25. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.